Hello, my name is Dan Eilers. I'm a software product manager for the Lisa at Apple Computer. And today I'm working at the IBM personal computer running 123, the popular spreadsheet package from Lotus.
And I'm Dick Gorman, also a product manager in the Lisa division at Apple Computer. I'm sitting in front of Lisa, the most powerful personal office system available in the marketplace today. We'll be comparing the IBM PC and Lisa, and many of the shortcomings that you'll see are a result of the underlying architecture in the IBM PC. We'll be discussing spreadsheet, database, and business graphics available on both of the systems. Lisa also has 4 other integrated applications which are available. These include word processing, data communications, free-form presentation graphics, and project management. Let's begin by comparing these systems, talking about the spreadsheet. Lisa Calc supports models which are up to 5 times larger than those models supported by 123. And the reason for this is twofold. First, Lisa has a full 1 megabyte of memory. Lotus on the IBM PC can only support up to a half megabyte of memory. Second, as Lisa Calc stores information in main memory, it compacts that information, thus allowing you to get more information in the full megabyte of memory. As a result, Lisa Calc supports models which are up to 5 times larger than those models on Lotus 123. The second major competitive advantage of Lisa Calc over the Lotus product is its ability to solve complex formulas and always give you the correct answer. I've actually prepared a very simple model, which I'll now open up on the Lisa desktop. As you can see on this model, there are 4 lines of information. Sales, which are estimated at $1 million, cost of goods sold, which are 60% of sales, profit sharing, which as we can see is 25% of profits, and then profits, which is the sum of sales, cost of goods sold, and profit sharing. Now, this is a complex model because of the fact profit sharing depends on profits, and then profits is the sum of sales, cost of goods sold, and profit sharing. As a result of this complex model, many spreadsheets will not give you the correct answer. Lisa Calc will. So for instance, if I change this 1 million to 2 million, enter that information at the keyboard, Lisa Calc quickly makes multiple passes over the spreadsheet until it gives you the correct answer. And the correct answer is $640,000. Let's now take a look at how the Lotus product on the IBM PC solves this same problem. Dan has now loaded the same model into the IBM. Let's go ahead and make the same change we did in the Lisa, changing the sales from $1 million to $2 million. As we can see, the IBM has come back with the wrong answer. It has come back with $725,000 as compared to the correct answer, $640,000. You'll notice that on the screen, the IBM indicates that there's a circular reference with the CIRC in the lower right-hand corner. It's what you would have to do now as a user is continue to make calculations. And we'll actually go through that process now and see what it takes until we get the correct answer. So Dan, if you would, go ahead and hit the Calc key, and as you hit the Calc key, count the number of times you've hit it.
1, 2, 3, 4.
Let's stop now. Let's see what IBM has come up with as an answer. It's $640,000 and $332. It's still $332 off from the correct answer. Let's continue to calculate and see how many times it takes until we get the correct answer.
5, 6, 7, 8, 9, 10. Aha, we have the correct answer of exactly $640,000.
So we can see that it took us 10 calculations on this very simple model to get the correct answer. And notice that the CIRC, the circular, is still indicated on the IBM screen. It doesn't tell you when you have the correct answer. The only way we knew for sure that we had the correct answer is we had a Lisa here to tell us what the correct answer is. The model which we just loaded into the IBM was a very simple model. And you can imagine with a much larger model, it would be very difficult to tell when data which was not displayed on the screen was done changing. With Lisa Calc, you never have to worry about getting the correct answer. You know that it always gives you the correct answer. The third major competitive advantage of LisaCalc is its ability to display and show values at the same time on the screen. You can display formulas along with their values and easily inspect to make sure that you properly entered those formulas. This information can then be printed out in a matrix form, which makes it very easy to debug that information. On the IBM PC with Lotus, you can only display either the formulas or the values, but not both at the same time. And when you print out this information, it's printed out in tabular form, which makes it much more difficult to debug a large spreadsheet to make sure you've entered all the formulas correctly. The fourth major competitive advantage of LisaCalc is its ability to load multiple models on the screen at the same time. No other spreadsheet on the market today allows you to bring up multiple models on the spreadsheet. LisaCalc then allows you to paste data between those spreadsheets. I will now demonstrate this for you on the Lisa system. I'm now going to select 3 budgets that I prepared and open them up on the Lisa desktop. The first budget is a division budget. Then we have an engineering and marketing budget. What we're going to do is take information from the engineering and marketing budget and paste it into the division budget. Very similar process to what commonly goes on within many large firms of trying to put together detailed information about a cost. And this process is also very similar to that typically involved in doing a forecast. In this case, I get my marketing summary expenses, copy the total expenses as well as the actual budget. I'll then come up and paste this information into the division budget. As I paste this information in, we'll see that the division budget automatically recalculates given this new information. Now let me go through the same process for the engineering budget. I come down, get the summary statistics, select the information, copy it, and then come up to the division budget and paste that information in. So as what I've just demonstrated for you is the ability of LisaCalc to take information between separate models and easily paste that information in. You can also do this with formulas as well as data. This is a very powerful feature which no other spreadsheet on the market today supports, the ability to bring up multiple spreadsheets on the screen at the same time and pass data between them. No other system on the market today allows you to bring a spreadsheet and a word processing document up on the screen at the same time and then pass information between those documents. The final major competitive advantage of LisaCalc is its flexible and high-quality printing. I've been working on a model that has 40 columns by approximately 30 rows. This model, when printed out on Lisa, takes up 1 page. When printed out on the standard personal computers, it takes up 8 pages of information. Lisa is able to print this model out on 1 page because it supports very small type styles. You'll also notice that Lisa allows you to print lengthwise as well as widthwise on a sheet of paper. I've now explained to you the major competitive advantages of LisaCalc over the IBM PC. Now let me address database issues. The Lisa system has Lisa List as its database. Lisa List supports models which are 10 times larger than those models supported by Lotus 123 on the IBM PC. The reason for this is that Lotus is constrained by the 1/2 megabyte of memory on the IBM. Lisa List is only constrained by the amount of storage on the Lisa system. The Lisa comes with a 5 megabyte hard disk, and Lisa List can take full advantage of this hard disk. Thus, Lisa List allows databases which are 10 times larger than those databases supported by the Lotus on the IBM. The second major competitive advantage of Lisa List is its ability to sort on up to 100 columns of information. Lotus 123 on IBM can only sort on 2 columns of information. This is a major advantage when working with large databases. The third major competitive advantage of Lisa List is that it performs data checking at the time of data entry. So as you're typing information in, if you happen to hit one too many digits in a telephone number, Lisa List will catch that at the time you type the information in. Lotus 123 does not catch data entry mistakes until you actually try to sort or use that information in some way. And then it'll come back and give you an error, and you'll have to fish through the database and figure out which entries were typed in incorrectly. What I've just described for you are the major competitive advantages of Lisa in the areas of spreadsheets and databases. Now Dan will describe in detail the competitive advantages of Lisa in the graphics area.
123 allows you to create basic business graphics such as line graphs, pie charts, bar charts, and so forth directly from spreadsheet data. Lisa Calc and Lisa Graph working together allow you to do precisely the same thing. There's a big difference, though, in the levels of integration, which I'll demonstrate for you, and also in the amount of time that it takes to create the business graph and then print it out. In fact, in tests that we've done, we've found that it takes approximately 5 minutes on average to create a business graph from spreadsheet data in the Lisa. It takes about 14 minutes, nearly 3 times as long, to perform the same operations with 123. Dick's going to show us exactly how we create a business graph from Lisa Calc data. Dick has both a Lisa Calc and a Lisa Graph document on the Lisa screen at the same time. He starts by highlighting the data that we want to graph in the Lisa Calc table. He copies that data, and then he'll paste it into the Lisa Graph application. This entire process is a 4-step process that takes approximately 15 seconds, and as soon as the data is there, you see the graph instantly. If Dick wants to preview the graph exactly as it will print out on the Lisa printer, all he has to do is first expand the size of the window so that he sees it entirely on the screen. Instantly, the graph is redrawn for him. And if he'd now like to change the type of graph that we see, he can do that by coming to the Graph Type menu and indicating, for example, a pie chart. The pie chart is now shown on the screen exactly as it will print. Dick has just created for you, in 4 steps and about 15 seconds, a business graph from spreadsheet data, specifically using Lisa Graph and Lisa Calc on the Lisa. Now I'd like to show you how to create a business graph with 123 on the IBM personal computer. What we see here now on the IBM monitor is actually an engineering budget on the 123 spreadsheet. It's the same engineering budget that we had on the Lisa Calc document from which we created a graph just a few moments ago. In order to create a graph from this data with 123, we first enter the graph mode. After we've entered the graph mode, we then input the x-axis range. In this case, the x-axis range is the first quarter through the fourth quarter of the year. We do something similar with data set A. Those are the total dollars actually spent in the engineering department last year. We then go to data set B. We highlight the budgeted numbers, hit return, and their input. Now, if we'd like to see the graph, we come over to the word View, and we say, Let's View. You now see a line graph from 123. In order to change from a line graph to a pie chart, we go to the word Type, hit Return, and then go to the word Pie. After indicating that we'd like to see a pie chart, we then go back to the word View on the 123 menu, and we ask 123 to give us a display of its pie chart. This is a pie chart displayed on the IBM personal computer monitor, in fact, the highest resolution IBM personal computer monitor. Compare it with the Lisa pie chart. You notice the very jagged edges around the pie chart on the IBM monitor. As I mentioned, this is IBM's highest resolution monitor, but it has about 1/3 the resolution of the Lisa's monitor. That's the reason that the Lisa pie chart looks like a real circle. And in fact, the Lisa pie chart looks exactly as it will when it prints out with our dot matrix printer. Speaking of printing, in order to print the Lisa Graph pie chart, Dick will show us exactly the procedure we go through. He simply uses the mouse to point to the File Print menu and then asks the Lisa to print the graph. At that point, the graph will print exactly as it appears on the screen. Now, in order to print the pie chart on 1, 2, 3, we have to go through a much more time-consuming process. Let's walk through it. First, we remove the pie chart from the screen. We come back to the worksheet. We now quit the graph mode, and we now actually need to quit the spreadsheet mode as well. What this does is bring us back to a low system level in the IBM personal computer. We now need to indicate that we'd like to graph, and the IBM personal computer tells us that we need to insert Lotus Graph Program Disk in Drive A and press Return. With 1, 2, 3, because of some of the limitations of the IBM personal computer, you actually have to be concerned about 3 different diskettes. Let me explain. First, we have a system diskette. The system disk has the spreadsheet that we've been working on so far for 1, 2, 3. We store all of our data on a data diskette. And finally, here's the graph program diskette. Whereas we've created a graph in the spreadsheet program, we can't print a graph from the spreadsheet program. What we have to do is insert this graph program into the IBM. Once inserted, we hit Return, and we're in effect rebooting the system with this graph print program, almost like booting another program. What we see on the screen as part of the graph print program are a variety of options associated with printing a graph. The first pass through that process to get to the first printed graph with 1, 2, 3 on average takes about 14 minutes for a typical graph. That identical process with Lisa graph takes approximately 5 minutes. Almost 3 times as long to create and print a graph from a spreadsheet with 1, 2, 3 on the IBM personal computer as it takes to create that same graph with the Lisa. A second important thing to compare between the Lisa and the 1, 2, 3 running on the IBM personal computer is the difference in the final output quality of the graphics. Notice, for example, with pie charts. The 1, 2, 3 output is on the top half of the page, and the Lisa's output is on the bottom half of the page. A substantial difference in presentation quality. Similarly, with bar charts. The 1, 2, 3 on the top half of the page, Lisa on the bottom half of the page. Notice how in the 1, 2, 3 case, the grid lines cut over the top of the bar charts, somewhat confusing to the eye. And notice also the fill patterns as compared with the Lisa fill patterns on the bar charts. In general, customers seem to agree that the final presentation quality of Lisa's graphics is superbly high. As you've just seen, we can create and print graphs 3 times faster with the Lisa than is possible with the 1, 2, 3 package running on the personal computer. In addition, the final output quality available from the Lisa is much higher, and we have much more flexibility to create presentation graphics with the Lisa than is possible with any software available for the personal computer today. Dick and I have demonstrated for you just 3 of the 7 outstanding integrated Office applications in the Lisa. Only through a full demonstration of all of our products can you appreciate the power of Lisa.